So today we're starting our triangle congruent proofs. And guys, when you are trying to prove two triangles are congruent, you must have three pieces of corresponding congruency. And what that is, that's based off of the video from yesterday where we talked about sides and angles and the combination of those sides and angles that give you a postulate or theorem that proves two triangles are congruent. So here we have another two-column proof. We're starting with line L is parallel to line M. So here they are. And that EG is equal to HF. So again, sometimes highlighting these triangles will help you to see that that is giving you a congruent piece already. So here we have our given, a parallel line, and our sides that are equal. So remember, if sides are equal, then we know that they are congruent. And I went ahead and labeled him as one piece of congruency. That gives me a side. And I know I can write that based off of definition of congruency. Now, because these lines are parallel, I know that angle 1 is congruent to angle 2 because if lines are parallel, alternate interior angles are congruent. And guys, I'm going to label that as my second piece of congruency. Remember, we need three pieces. And then the fourth step, notice that FG is a segment between the two parallel lines that is shared between the two triangles. So therefore, if a segment is shared, we call that reflexive. So FG is congruent to FG, giving me my third piece of congruency. So guys, don't go off of the order in your proof. Go off of your diagram. So we were told these two pieces were congruent. We have proven that these two angles are congruent. And then we use reflexive for the middle line. Therefore, side, angle, side, excuse me, is our congruency statement. Alright, so based off of our diagram, side, angle, side, here's the congruency statement. Triangle EGF is congruent to HFG. Remember, order of your congruency statement is important. You're telling me that E is congruent to H, G is congruent to F, and then F is congruent to G. So be careful right there, okay? Alright, example number 2. This one looks kind of crazy, but sometimes for visual learners, this diagram is easier to read because we can visually see the two triangles in question. Now we're given that WX is perpendicular to XZ. So WX, XZ, so there's a right angle. YZ is perpendicular to ZX, so there's a right angle. And then WZ is congruent to YX. So the first thing that I said was exactly what I marked in my diagram. Angle 6 and angle 3 are right angles. By definition, perpendicular lines form four right angles. Therefore, triangle XYZ and triangle ZWX are right triangles by definition of right triangles. So remember back in one of the first or second lessons of this unit, we talked about if a triangle has a right angle, he is considered to be a right triangle. And then XZ is congruent to XZ because of reflexive. Do you see how this little bitty line is being shared between the two? And now because of that, we can prove hypotenuse leg. Now, I like to give this example because some students think that, well, I have a right angle and I have a leg, so I'm done. The problem with that is the hypotenuse and the given leg are the same. So therefore, you have to prove reflexive in order to be able to use hypotenuse leg theorem. And then our third example. This is probably one of the harder examples, and some students like to break away the two triangles that we're trying to prove. We're trying to prove JKL is congruent to MLK. So if you want to separate those two triangles into two different drawings, you're welcome to do so. We're given that JK is equal to ML, and we're given that angle JKL is equal to the measure of angle MLK. So that guy right there. So that's our given. The first thing I'm going to prove, if these two segments are equal, then I know that they are congruent. So that gives me one piece of congruency. And again, if the measures are equal, then the angles are congruent. So that gives me my second piece of congruency. And then notice that this line at the bottom, KL, is being shared by both triangles. So therefore we call him reflexive, and that gives us our third piece. So go back up to your diagram. We can prove the two triangles are congruent based off of side, angle, side congruency.